Hi, this is Romy, and today we're going to discuss the longest palindromic substring problem that is lead code medium level one. This comes up often in interviews. Let's first define what is a palindrome. A palindrome is a string such as these, ABBA, ABA, or the string of repeated characters. It reads the same going from left to right and right to left. A unique property about palindromes is that we have a center and the characters to the left and the right are the same, going from both directions. So we start out at here, B, and we go out and expand around the center. The character on the left is the same as the character on the right. We can use this to our advantage in our optimal solution later on. So first, let's talk about a brute force solution. A brute force solution would be to check every possible substring and then check for each of those the longest one. The runtime is not efficient. It's big O of n cubed. A better solution would take advantage of that property of symmetry around the center. We have two types of palindromes. We have even and odd length palindromes. For our examples here, the even length palindrome has two characters in the center, and then when we expand around the center, we're actually expanding around these two characters. For the odd length palindromes, we expand around one element here. Let's take a look at our solution using that property then. So here, we first check if the input string s is less than 2, meaning that if it's only one character or less, then we just return the input string s, since that is by default a palindrome. Then we initialize a start and end variable here that will be used to keep track of our current longest palindrome that we're finding. We go through each character in S starting from 0 and treat each I as a potential center. We expand around the center for odd length cases of palindromes and again for the even length cases. That's why you see I and I here given for odd length palindromes. Since we discussed that for odd length palindromes, there is only one element in the center, but for even length palindromes, there are two elements in the center. We take the bigger of those, and then we check if that length is greater than our current best window. So we check if the length is indeed bigger than our current one. Then we update our start and end using I and some math using half of the length. So I plus half of the length to get the end indice. And similarly for the start indice, it's I minus roughly half, length minus 1 divided by 2 to take care of both odd and even length palindromes. This expand around the center helper function takes the string, a left and the right pointer, and it expands while the characters are still the same. Left minus minus and right plus plus. Once it gets out of this while loop, it means it has overshot by one indice, both on the left and the right. We return right minus left minus 1 to take care of them. At the end of our function, we return the substring of S using our start and the end indices. Let's take a look at the example, BABAD. A palindrome is BAB or ABA. They are both size of length 3. And the solution is correct, BAB. The runtime of this algorithm using the symmetry and expander around the center is big O of n squared. We go through each character in S, and from there we treat that as a potential center and expand outwards, potentially n characters long in the worst case, so big O of n squared. And for the memory, it's big O of 1, since we just use variables. This is the nice solution for LPS using symmetry and expander around the center. If you like this type of videos and clear explanations, please subscribe for more. Thank you.